Okay, in this lesson I want to walk through how to get some additional functions in the Chapter 5 time value of money calculations. I'm going to show you how to do some add-ins in Excel, and then we're going to work through some problems. So first, if you go up to the Microsoft Office button, you click on that, and at the bottom you're going to have to go down to these Excel options. So we'll click on the Excel options, and on the left hand side you'll notice that you'll see some Excel options, and we're going to select add-ins. So if I select add-ins, you'll notice at the bottom of the page it will say manage Excel add-ins. I'm going to hit go, and what I would make sure is that you at least have the first two checked off. And if I hit OK, since mine is already in there, it won't process anything. But if you have not had these in here, then you'll have to wait a little bit for it to pop in, and just hit OK and go through the functions that request to get them added in. And the reason we did that is because when we go to this f of x function, now if I click on the f of x in Excel, under these categories of financial, it's going to have a lot more functions. You know, before you check those add-in boxes, it might have 20 or so, but this is going to give us more than enough what we need for this course. So one of the first things I want to show you is if we look on page 139, I'm going to walk through the example with they do a future value problem. So if we go to financial, we're going to find FV, so we hit that and hit OK. And it tells us in the problem that the rate is 0.08 or 8%, so we put in 0.08. The number of periods in this case was 7 for 7 years, so it's annual. There's no money added to the account at the end of the time period, so that's why it would be 0, but we can leave it blank here. In Excel, we're going to put in a negative $500. It's from your perspective, you're investing $500. It's telling us how much we would have in the future. So if we did do this, it matches up to our textbook example on page 139. So we have $856.91. So I'm going to hit OK there. I also pose the question, what if this was compounded monthly instead? Well, in order to do that type of problem, I'm going to go back up to this f of x again, financial. I'm going to find future value. I'm going to hit OK. Now the rate was 0.08, but if it's compounded monthly, I need to divide that by 12 to adjust for the appropriate interest rate per month. And the number of periods, since this was 7 years, but there's 12 periods in a year that we're doing this, I need to multiply by 12. Finally, there's no payment. My present value is the $500 invested. So we can see that when it's compounded monthly, the future value is going to be a little bit more because it's compounding more frequently. So we got $873.71 compared to our original value of $856.91. In fact, let me just kind of cut and paste this up here. I'm going to put it up there, kind of where I need to go with the future value. Okay. So the last thing here on this page, I want to do the example with the interest rate. So this is on page 139 again, and we're going to solve to show that the rate is 6%. So in f of x, if we go into that, there's going to be a rate function. So under financial, we'll look for rate, R-A-T-E. I'm going to hit OK. This problem, it said the number of periods was 10 years. There was no payment added to the account at the end of the time period. The present value was negative 11,167, the amount we invested. In the future, we expect to receive $20,000. We look here, we can see 0.06. If I hit OK, it tells us 6%. But I think it's always a good idea, especially in Excel, to make sure you round these things out to 4 decimal places. So I'm going to increase the decimal point 1, 2, 3, 4, and all practical purposes, that is 6%. Okay, let's go to Chapter 5, page 145 for a couple more examples. We're going to have a future value of an annuity, regular annuity. So what if I invested so much at the end of each time period? How much would I have in the future? So again, I'm going to go to f of x here. Under financial, I'm going to find future value, FV. I'm going to hit OK. The rate in this example was 0.06. Number of periods was 5 years. The payment was the amount of money we were adding to the account at the end of the time period. So if I invested $500 at the end of each time period, and in this case we have no present value, there's nothing that was input into the account at the beginning of the year, so it tells us that the future value we'd have $2,818.54 if I invested $500 a year at the end of every year for 5 years. One other thing I want to do is I want to copy this one and paste it over here. And kind of the question is, well, what if this had been an annuity due? That is, the payment happened at the beginning of the time period as opposed to the end of the time period. Well, if I pull this function back up, if I go to this f of x, and we have the rate, number of periods, and payment, there's a field down here called type. And if I type in the type 1, it tells me it's a annuity due, so the payment happens at the beginning. And we can notice here that the future value amount is going to be a little bit more because instead of waiting a whole year to invest that money, we're putting it at the beginning so it earns interest that entire year. So I'm going to hit OK for that one. Last one I want to do is a payment example. This is on the right hand corner, bottom page 145. So if you were figuring out a mortgage payment, a car payment, but in this example we're going to go to f of x, go into financial, we're going to find PMT, and I'm going to hit OK. The rate in this example was 0.06. The number of periods was 8 years. And the present value is going to be 0. And in this case, we had a future value amount of $10,000. Okay, so we put in the 10, 1, 2, 3. And we can see that we match up with $1,010.36. Okay. One other example I want to point out with payment, kind of get this one in here. Let's say that you were trying to do like a car loan payment. So let's do another one of those. So let's do f of x, find payment. I'm going to hit OK. Let's say you could borrow, we want to get a new Toyota Camry at 0.06%. We're going to divide that by 12 because most car payments are monthly. Number of periods, let's make it 60 for 5 years. Let's say you borrowed $20,000. So you receive $20,000 and you give it right back to the car dealer to buy the car, but it's a positive cash flow from your perspective. And the future value was 0 because you have paid off. Well, it tells us that our car payment would be $386.65. So I'm going to hit OK there, and then we can see that. And I'm going to stop there, and then in the next video I'm going to show you some additional problems in Chapter 5 to help you with the time value of money calculations.